Okay, now this is another one of my favorite lessons along with Castle Walls. Now we're going to have a story about jail. And the way I talk about simplifying radicals is the radical acts as jail. And you can escape from jail if you have a partner or partners to escape from. So for instance, this is a square root, and in a square root you need two of the same thing to undo the square root. So I say you need one partner or a pair to escape from this jail. This is a cube root, which I call that more maximum security prison. And so you need groups of three to get out of jail. So for instance, we have this one, a square root of 25x to the third. And what I'd like to do is factor everything. So I'm going to say, and I put it into prime factors. So 25 is going to be 5 times 5. So I can rewrite this as 5 times 5 times x times x times x. Now notice that there are two 5s, so the 5s are friends. So the 5s can come out of jail and they turn into 1 5 on the outside. The square root of 25 is 5. The way I rationalize that with my story is that they're such good friends now that they stick together and are 1 5 for the whole rest of their lives. They're such good friends. So now we're going to move on and look at the x's, and we do everything separately. We do the constants, and then we x's, and if we had another variable, we do that separately. So we look for a pair. So we have this pair of x's. These x's are friends. So again, these can come out and turn into 1x on the outside. But this poor little x in here is left all by himself without any friends. So he's stuck in jail. So our final answer for this one would be 5x outside of the radical square root of x. And that would be simplifying the radical. And just a hint, you always need to simplify a radical. It's kind of like reducing a fraction. If you leave a radical like this, even if it's the correct answer, it's not the correct answer because it hasn't been simplified. So let's move on to this other example with a cube root. So I'm going to talk about, so maybe you don't see right away. We could see right away that 25 was 5 times 5. But 54, let's sort of break this up. So I'm going to what's called prime factor this. So I look for prime numbers, and those are like 2 and 3 and 5 and 7 and 11 and 13, the numbers that only 1 and itself go into. So I'm going to start with 2, so because 2 goes into 54, and so we're left with 27, and 2 doesn't go into 27 anymore, so I can go to 3. 3 goes into 27, and we're left with 9 and 3 and 3. So we can write 54 as 2 times 3 times 3 times 3. So now we have the cube root of 2 times 3 times 3 times 3. And then we have x to the 6th and y to the 8th. So we have 1, 2, 3, 4, 5, 6. And then I'm going to just write it under here. 2, 3, 4, 5, 6, 7, 8 y's. And I'm going to erase this, get this out of the way, so it isn't so confusing. So since this is a little bit maximum security, more maximum security prison, we need to take out groups of 3. 2 doesn't have any friends. The 3, there's a group of 3. So we can take these out to the outside. We have 2 groups of 3's of the x's. Now we can talk about the power over root sort of as a shortcut. We can go 6 divided by 3 and know that that's 2, so we know that we have an x squared on the outside. Now we can do the y's. We have 3 there, 3 there, and then we have 2 left over, which isn't a full group of 3, so those are going to have to stay in jail. Now the shortcut would be 8 divided by 3, which would be 2, with 2 remainder. So these 2 y's, so it's going to be a y squared that comes out here. So our final answer would be 3x squared y squared, and then it'd be the cube root of everything that's left inside that doesn't have any friends to escape from jail. So that would be the 2, and that would be a y squared. And that would be our final answer. So I'm now going to continue my story of jail with quotients and when we have dividing. So the rule is these are certain kind of criminals because they're in the cube root or the little more maximum security prison. So they can commingle with other prisoners that are the same kind of prisoner. In other words, if these are the same kind of radical, you can combine them. So this can equal 5, and then we can just have one cube root, 40 x to the 5th, y to the 7th, divided by 5y, and now we can reduce that fraction because these are the same kind of radical. They're the same kind of jail. So we can do 5 goes into 48 times, and this y, it's a y to the first, little hint, you can write a 1 there. So this y, and that makes that y to the 6th. So I'm going to rewrite this. It's going to be 5 times the cube root of 8 x to the 5th, y to the 6th. Now again, this is cube root, so we can either recognize that the cube root of 8 is 2, or we can break everything up and look at it that way. So let's do that. So 5 times the cube root of 2 times 2 times 2, and then x to the 5th, y to the 6th. So these 2's can come out, and so we're going to have 5 times 2. They multiply when they come out. And then how many groups of 3 can come out of x to the 5th? Well, we can go 5 divided by 3, which is 1. So there's 1 x on the outside, and I'm going to put the jail here, which means there's still 2 x's left on the inside. And then 6 divided by 3 is 2, so that means there's y squared, and all the y's come out, so this would be our final answer. So again, these have to be the same kind of radical in order for you to combine them. So that's my hint for that. So I hope you enjoy my jail story. It actually is a good way to help you remember how all these things fit together. So have fun.